What the f... Who moved that? Bruh. Testing. Testing. Alright, beauty. Let's go. And let's continue. Let me open this up. And then let's continue this.
In this video, we are going to talk about game objects and components. We are going to add some extra information about these important elements in Unity. There are many game objects we can put in our scene from the menu of the Unity editor.
Okay.
Empty, an empty game object. It is a game object with just the compulsory transfer component, and it is useful, for example, as a parent of a collection of game objects. For grouping objects
Huh. Sure. Oh yeah, let me do this. Okay. Empty an empty game object. And it is just the compulsory transform component. And it is useful, for example, as a parent of a collection of game objects. What? For grouping objects. Oh, empty. Empty is a game object. With just the transform component, it is useful as a parent of a collection of game objects. For grouping objects and work with all of them together. Oh, okay.
And work with all of them together, sure. Also making some transformations easier. We can also use it just to add components and create a specific game object. Imagine, for example, a collection of bricks. We can create an empty game object called wall and make all the bricks children of the wall. By moving or transforming the wall, I'll be moving and transforming the bricks. Cube, sphere, capsule, cylinder, plane, and quad. Simple game objects we can create inside Unity. And they are perfect for our first examples without having to import anything or creating of it. They are also useful for creating more complex elements, transforming and combining them. Lights. We can add lights, of course, to our scene using the Unity editor. Lights such as directional, point, spotlight, and array. Cameras. Besides the main camera, added by default in each scene, we can add several additional cameras that we can enable, disable, or make them render into different areas of the screen, for example. And many more. Okay. We can add interface elements, we can add clothes, ragdolls, trees, etc. Now we are going to talk about the most important components. We can add many different components to a game object. The main ones are transform, okay? Always present by default in any game object, even in an empty game object, and holds the position, rotation, and scale of the object. The mesh filter stores the polygonal mesh of the game object, so it's geometry, a collection of polygons, triangles. The mesh renderer. Its function is to define how the mesh is going to be rendered, painted in the screen, what materials and what properties we are going to be using. Collider. It's another geometry that our game object is going to use when colliding with other objects. For performance reasons, this collider is usually simpler than any original geometry of the object. It is very time-consuming to calculate in real time the collision between complex objects, with thousands of.
Correct. That's why there are hitboxes. Oh, he's just talking. He's talking about hitbox. When he says collider, he means hitbox. But I guess collider is the official term.
Triangles, polygons. For example, it's quite common
cool.
to use a capsule for 3D human characters. This makes the process of calculating collisions easier, but less accurate. Rigid body. Required when we want our object to be under the control of the physics engine, gravity, and reaction against collisions. This means that our game object will be reacting to collisions and forces without us having to control this process by code. Sound, by using audio source and audio listener. We can add the audio source component to any object able to produce sounds of music, and the audio listener component to the object that has the player's ears, the mic or microphone of the scene. Scripts, very important components. It will
That's
control the behavior
convenient,
of the game
honestly.
object using code. We can add more than one script to our game object. But we have many more, such as particle systems, animations, etc. So we can add any component to any game object. We can enable, disable it, we can remove it, we can edit any of its properties in the inspector view. And from inside our scripts, our code, we can also get access to the game object's components. We can add them, we can modify them, consult or change their parameters. So we can do all these things with the components using the Unity editor or inside our code in a dynamic way. So okay, we have seen more info inside our code.
Okay. Add any component to an object. Enable or disable it. Remove it and edit any of its properties in the inspector view. Oh, yeah, sure. I should stop touching my facial hair because it's kind of weird.
In a dynamic
Okay,
way.
modify the components
So okay, we have
from
seen more
inside our
information about these
script.
two important Unity
Makes
elements,
sense.
game objects and components.
Sick. Thank you.
Hello again. Physics are a very important element in many games, interactive applications, and virtual and augmented reality. With a physics engine, we won't have to be worried about simulating forces, collisions, and the most important interactions in a real environment. Of course, Unity integrates a very powerful physics engine. Unity has a very powerful physics engine. It is called physics. If we want a specific game object to be under the control of the physics engine, we have to add the component rigid body. So the object will be under the gravity force by default, and other forces produced because collisions with other objects or forces we apply in our scripts. For collision detection, we also need to add the component collider. We will be using rigid body for things the player can push or move by using forces. When an object has the rigid body component, and it is non-kinematic, it won't be convenient to change its transform component, but to change its position and orientation by applying forces or torques. It is also possible to add joints with other objects in order to create more complex behaviors. Rigid bodies, clicked as kinematic with the isKinematic property, are not going to be under the control of the forces, and they are used for special cases. For example, when we want to detect collisions, but without being under the control of the physics engine. We can also add only the collider component to the game object, without rigid body. In this case, we are modeling static objects, for example, a wall. So we can collide with the wall, we can bounce back, but the wall is going to be static. Unity has also a 2D physics engine.
Hold up. Oh, add only the collider component without rigid body. Add joints, okay. Okay. So kinematic is like we tell it what to do, not that it's being acted upon by the physics engine, I guess. And we can add only the collider, so only a hitbox, basically. Fair enough.
Unity has also a 2D physics engine. It is called Box 2D. We will be using it, of course, when developing 2D games with 2D game objects. When doing it, all the elements we are going to see, we have the 2D suffix, such as rigid body 2D, collider 2D, collision 2D, on collision enter 2D, and so on. These elements can also be found in the editor, in the component menu, in Physics 2D. We have many properties in a rigid body we can change, of course. The most important ones are mass, the weight of the object in kilograms; drag, how much resistance from the air the object has when moving in a linear way; angular drag, how much resistance from the air the object has when rotating; the use gravity property, if we want the object to be or not under the control of the gravity force; and the property is kinematic, if the rigid body is kinematic or not. Additionally, we can create something it is called physics materials, in order to better adjust the friction and bouncing factors of the object. We can create these physics materials and we can attach them to the objects in order to better control the reaction of the object in front of friction and collisions.
We can create physics materials. Okay, I guess I'll figure it out.
Okay, so we have carried out an introduction to the physics engine in Unity, which is basically controlled by adding the rigid body component to our game object. With a rigid body and a collider, the physics engine will update the position and rotation of our game object in front of collisions and forces.
All right, poggers. Did that check it? Yes. From kinematics to physics,
Okay, we
sure.
have seen in the previous videos that this first example we have developed was developed using what we call kinematics. We were in charge of the movement of the sphere. So in the update, we translate the exact amount of movement we want each frame. What we are going to do now is to transform this first example into a physics example. And as a result of that, you're going to see that we are going to have some advantages. Okay, in order to change this from kinematics to physics, the very first thing we have to do is to select our sphere, and we have to add a very important component. So we go to the component menu, and we go to the physics section, and the very first thing we have to do is to add what we call a rigid body. When we want to control something using the physics engine, it is going to be necessary to have this rigid body. When something has a rigid body, by default, this game object is going to be under the control of the physics engine. In this case, because it's a 3D example, we go to rigid body, but when you develop something 2D, we have the more or less the exact kind of components for 2D. In this case, we add a rigid body. As you can see here, we have the rigid body, and we have the default values, okay? And we are going to leave now the default values, which is a mass of 1 kilogram, and no drag. This means that there is no friction because of the air with a rigid body. In this case, we add a rigid body. As you can see here.
Oh, and it just adds.
We have.
Okay. Sure, it just like adds right away. All right, fair enough. Bang, and then bang, and it just adds. All right, cool.
The rigid body, and we have the default values, okay? And we are going to leave now the default values, which is a mass of 1 kilogram, and no drag. This means that there is no friction because of the air when moving in a linear way, and the angular drag, a very low value. This is the friction of the air when, in this case, the sphere is going to rotate. So we are leaving these values by default, okay? And what we are going to do now is to change the script, okay? So we are going to go to move, and we are going to change, because now we are not going to change to move. And what we are going to do now is to change the script, okay? So we are going to go to.
It's just bouncing because it's iOS. Got it. It's a Mac. He's on a Mac.
To move.
Actually, I guess it would be Mac OS if it was on a Mac, not iOS. Am I right about that? Okay. So I actually want to make another script called physics move. And then that's fine right now. Actually, I don't know why I have my other tab open or my other window open, because I'm not using it. Okay, there is my Visual Studio.
And we are going to change,
Now
because now
let's
we
keep
are
going.
going to change the position of the sphere in our update, okay? So this is the very first thing we are going to do. We are going to remove what we have in the update. We are going to use another update. An update, we are going to provide much more information in future videos. When we work with the physics engine, as you are going to see, it's going to be very common to work with this update. It is called fixed update. Okay, so the fixed update, the main difference with the update is that we are going to, Unity is going to call it on regular basis. Okay, so instead of calling this fixed update every frame, what Unity by default is going to do is to call to this fixed update on regular basis. By default is
Yes? Why? Yes, but I can hear it. I'm like, oh. And that's all you did? You just puffed it up? Yeah, it looks very... It looks more Santa Clausy than usual. For sure. Yeah, he's playing Genshin music and I'm like tripping out. I'm like tripping because because I always log out in Mondstadt and he's playing Mondstadt music. So inking. Why did you do private? That's my real question. Oh, why does it do private? Why does it do it private? Wait, so if I do this, okay, never mind.
about 50 times per second. And this fixed update is synchronized.
50 times per second? 50? I mean, that's like, oh, fixed update. That would make more sense. Why didn't we just learn that? Why didn't I just learn that from the beginning?
With the physics engine. So they work together, okay? So it is very common to use this fixed update for the kind of things we are going to do right now.
So instead of calling this fixed update every frame, Unity by default is going to do it about 50 times per second. Synchronize with the physics engine. Oh, okay, sure.
To apply a force to our sphere, a constant force, okay? So instead of translating the sphere, what we are going to do is to apply a force, and by applying a force, the result is going to be that the sphere is going to move, okay? Okay, so what we are going to do is, first of all, we are going to add here a component which is called rigid body, okay? So the component we have added to our sphere. We are going to get this rigid body. We are going to get it in the start, okay? And we are going to do that because it is very important that in the update and in the fixed updates, the code we put.
I have force. And applying the force is going to cause the sphere to move. Add a component called a rigid body.
Put there, it is very important to be very optimized, okay? So instead of getting the component from the fixed update directly, I'm going to get the component in the start. I'm going to store this component in this variable RB. the rigid body, and we are going to get access to it in the fix update. This is going to be faster than getting the component every time. So this is what I'm going to do in the update, in the start, sorry. Remember that the start is going to be executed at the beginning and only once. And we are going to get access to the component using a method get component, okay? This method get component is going to be the one we can use in order to get access to any component we add to our game object, in this case, the rigid body. Okay, if you're familiar with C#, we are doing that using generics, okay? The way we have in order to get access to generics, okay? So in this way, with this get component method, we get the rigid body component, we store it into this variable RB, and this is much more convenient than using get component inside the fix update, okay? Just because performance reasons, okay?
Okay.
This get component method, we get the rigid.
Okay, but why is it like... What are these again? Type of parameters. Make it possible to design classes and methods that defer the specification. Okay, hold up. Generic list T. Okay, it doesn't really matter, I guess, right? Design classes and methods that defer the specification of one or more types until the class or method is declared and instantiated. Okay, hold up. So it's like a placeholder? It's like a placeholder variable, I guess? Yeah, wait, so this is... They did this for like arrays in Java. But whatever, it doesn't matter. It's just a parameter inside a angled brackets, I guess.
Body component, we store it into this variable RB, and this is much more convenient than using get component inside the fix update, okay? Just because performance reasons, okay? So in this fix update, we are going to be using this rigid body component, and we are going to use a method called addForce, okay? Again, this method has different...
Okay, so this is the variable type. Wait, the variable type is rigid body and it's not camel case? Ah! Actually, what would that be? No, that's not camel case. Whatever, it doesn't matter. Okay, great. No, that's there. So let's just do what is it? Private rigid body is the variable type, is object type. So just declare that there. And then I guess we're just gonna do the equal there. Oh, wait. Get component. Sorry, get component. Why? Yep, it does that automatically, so that should be good. Is that not? Is that like not what? Ow. I rigid body. Okay, this may not work. This may not work. This may be an out-of-date course, and if it is,
Possibilities in the arguments. We are going to use another possibility.
then
Okay, we
I'm
are going to use
going.
this first one.
And if it is outdated, then that's not gonna be fun. Okay, never mind. Lol, I'm dumb.
We are going to specify a vector 3, one of the elements we can create by default in our scripts. So we are going to use new vector 3, okay, and we are going to specify the 3 components of this vector. And we are going to do that in a very similar way to what we did in the kinematic example. We are going to use input, get axis, horizontal. Okay, this is going to be the first value. The second value we are going to be using is 0, remember. And for the third one, we are going to use input, get axis, again, in this case vertical. Okay, so as you can see, we are doing something very similar to what we did in the update. We are specifying, in this case, a vector, which is going to specify the direction where we want to put.
Okay. So this is basically just saying push. Dot, what is it? Add force. New, why am I making a new vector though? Alright, I guess. Sure. Guess that's fine. Input dot get axis. This is gonna take a long time for me to get used to. Why? Okay, and it's annoying that he puts them on different lines. But alright. And do I seriously need 3? Yes. Nice. Vertical baby, let's get it.
Push the sphere. So we are applying a force to the sphere in order to push and move the sphere in a specific direction. And this direction is specified by this vector. Okay, so now we can make this vector, the length of this vector, longer. Okay, so we can change the magnitude of the force. And in order to do that, we can multiply this vector by a value. So this is one of the possibilities C# offers us. Okay, C# has something called operator overloading. So we have, and this is what we are going to do now, we have something very useful, that is, we can multiply by a scalar, in this case a float. Okay, so we can, for example, use something called force value instead of speed. Okay, so now we have to define this force value. Okay, so instead of speed, we are going to use force value. Okay.
Okay. Why is it public though? Whatever. It doesn't matter. And then multiply. Sorry. Multiply this, I think. That's why. That's why he did it. I need to stop picking my face. Gosh. And that's fine.
So what this force value is going to do is
Sorry,
multiply the
hit the
3
mic.
components of these vectors by this value. Okay, so if in this value we put, for example, 5, 5 is going to be multiplied to the value of the get axis horizontal and vertical. So by changing its force value,
There's
we
a
are
fly
making
in
this
the
vector,
room.
the module of this vector longer, and with that, the magnitude of the force. So the bigger this value, the more force we are going to have in the sphere. Okay, so this is more or less the idea. So instead of using the update, remember we are using this fixed update. And when we use these kind of forces, constant forces, it is convenient to make this in the fixed update because it's going to be synchronized with the game engine. Okay, this is with the physics engine. This is the idea. Okay, to have this synchronized with the physics engine. So we are going to save this script, and we are going to go back to Unity. So if we select the sphere, remember we have right now, as we can see, we have the rigid body. Okay, now we have the discrete move. In this case, with the force value of instead of the speed. So we are going to use as initial value, for example, 5. Okay, don't forget that we have to initialize the value in the editor. Okay, and we have a collider. Okay, this is very important. Thanks to the fact that we have a collider, this means that our sphere is going to have collisions and react against collisions with other objects. This is the case of the plane. The plane has also a collider. As you can see, it has also a collider. So
Oh, they automatically get colliders. All right. That makes sense.
thanks to that, the sphere is not going to fall down. Okay, and thanks to the fact that the sphere has a rigid body, we can, as you can see, the sphere is under the control of the physics engine. Okay, in the plane we don't have rigid body, so this means that the plane is going to be static, it's going to be fixed in this position, it's not going to fall down. But the sphere has a rigid body, and remember, use gravity is activated, so the gravity is going to be applied to the sphere. Okay, so let's run to see what happens. So here we have the game view, and as you can see, we can move the sphere in a very similar way. Okay, as we did when we were using update. The main difference here is that the sphere is rotating. Okay, so we can see that. We can pause.
Hey, that's sick, bro. Hey, that's sick, actually. Yay, I made a marble game. Okay, it's not working. Oh, because I don't have this. Don't have that at anything. So use gravity. All right, yeah, that should be good. Woo. And if I just let go, then it'll just roll, baby. Okay, that's cool. But it like doesn't have any. It doesn't have any friction. Right? So if I do this, it's just gonna roll forever. Okay. So let me retry this. If I just do this, it is literally just going to roll forever. Okay. So if I do like 0.25, then it's gonna slow down. Okay. So if I like do this, then it's gonna slow down. Poggers.
You can see that.
That's pretty epic.
Okay, if we visualize the two views at the same time, okay, you can see that in the left, the sphere is really rotating. This is the main difference, of one of the main difference with the previous approach. And there's another thing that is going to happen. If we fall down, okay, the sphere is going to disappear, okay? So because of the gravity, okay?
Okay.
So as you can see,
Okay.
something very interesting, okay?
Okay.
Something very interesting. We can, right now, okay, rotate, we can roll over the plane, okay, because of the action of the force. And now the plane is essential in order to keep the sphere in the same position, in the same vertical position, okay? So we are going to change something now, something very interesting also. We are going to change in the rigid body this drag, okay? Now it's 0. We are going to use, for example, something such as 2. And the reason is because if we move the sphere and we
Wait,
release
what?
the key or the button, now something very interesting also, vertical position, okay? Okay, we can, right now, okay, rotate, we can roll over the plane, okay, because of the action of the force. And now the plane is essential in order to keep the sphere in the same position, in the same vertical position, okay? So we are going to change something now, something very interesting also. We are going to change in the rigid body this drag, okay? Now it's 0. We are going to use, for example, something such as 2.
Okay, I already
And the
figured
reason
this
is
out.
because if we move the sphere and we release the key or the button, we want the sphere to stop. We don't want to have a constant movement of the sphere. Okay, so you see, if I release the key, the sphere stops. And this is because the drag, the friction with the air, is going to make finally the sphere to stop. And this is very interesting in this example, okay? So as you can see, we have transformed our first example from kinematics to physics by adding a rigid body, and instead of applying a translate in the update, we are applying a force. In another update, it is called fixed update, that it is synchronized with the physics engine, okay? And we are pushing in this way the sphere, so the sphere starts to roll over the plane. So we have a very similar behavior, but with many advantages, as you are going to see in the future.
Cool. I want to make it bounce, but I don't know how to do that. Okay, here we go.
Sphere. We are going to do something very interesting in many games is let's make the sphere jump, okay? So something very interesting in order to provide some interesting functionality and to be able to make this first example a bit more complex, okay? So in order to do that, what we are going to do, of course, is to edit the script, okay? If you remember, we were adding a force.
Did I get it?
The force we are adding in the fixed update is what we call a constant force. A constant force gradually changes the velocity of the game object, okay? So this kind of force is not going to be very interesting in this context, okay? Because we want to make our sphere jump. So this means that when we detect that we press the jump button, we want to change the velocity immediately. So we have to simulate somehow that we are kicking the sphere in the y-axis, okay? So we are going to see that the force we are going to apply is going to be
explosion.
It's not going to be a constant force as the one we are using in the fixed update.
Gonna be explosion
because it is not
force.
A constant force. We are going to make this change not in the fixed update. We are going to do it in the update, okay? Because in this case, we are interested in detecting when the user is pressing a specific button. And the right place generally in order to do that is in the update, okay? So this is what we are going to do. We are going to go to the update again, and we are going to use a condition, an if statement, where again, we are going to use the object input, and in this case, we are going to detect a button. We have several possibilities for get button, okay? We can use this one, get button, and get button is going to return true when we are, or while we are pressing the button, okay? So what we want to do is to jump when we press the jump button, but if we keep the button pressed, we don't want to continuously be jumping, okay? So we want to jump only when we press down the button.
True.
And if we keep the button pressed, we don't want to jump anymore. We have to release the button and to press the button again if we want to jump again. So in order to do that, instead of using get button, that it is going to give us true all the time, we are going to use get button down. Get button down is going to give us true the very exact moment where we press down the button. But if we keep this button true the very exact moment where we press down the button. But if we keep this...
Okay, for some reason, I heard like a doop, like a little, like an instrument or something when I paused. Okay, if so, isn't there a different way you can do this? Like, couldn't you do RB dot add explosion force when get button down, I guess, or whatever? instead of an if statement. Let me try that. Sorry. Add explosion force. Float explosion force, vector 3, explosion position, explosion radius? That's not what I want. Let's see, add, what other kind of force is there? Add force. Alright, no, I have no clue what to do. So I will not be doing it.
Button pressed, the next times the
And also I need to change the camera angle. Just because, just because I won't be able to see it jumping. No, thank you. So if I do 90, oh no, 45. And maybe 20, maybe 20, 23. Let's do 20 for this. And that should be good. But I just a little bit far. But that, it should be fine. Okay. Just kidding. 20 is fine. Okay, let me try 18 because I still want the edge in the frame. 16. Yeah, 18 is fine.
the next frames, this is going to return false. We have to release again the button and to press again, okay, in order to get another true. Okay, so this is very interesting in this context, okay? So what we are going to do is to detect a specific button. In the input manager, this button is called jump, okay? So we go to jump.
Okay.
Jump is going to be the jump button in the gamepad or the spacebar in the case of the keyboard, okay? But this is not the only thing we have to do here. Because we have another thing we have to try to avoid. So imagine that you are jumping and you are in the air, the sphere is in the air. We release the button and we press the button again, okay? So theoretically speaking, we are going to jump again.
Okay, he's thinking of everything that I was gonna.
Many possibilities. We can detect if we are over a surface. Okay, this is one possibility. The possibility I'm going to use here is to see which is my velocity in the y-axis. Okay, so I can do that accessing to the rigid body, in this case to velocity, and in the y-axis. If this velocity is less than a specific amount, very little amount, this means that we are probably over a surface, okay? So this is the way we are going to do that here. Because this velocity can be positive or negative, we are going to use math f ABS, which is going to give us the absolute value, okay? So if this magnitude is less than, for example, 0.01, very small magnitude, we are going to jump, okay? So this means that probably we are going to be over a surface, okay? So we are not going to allow several jumps when we are in the air, okay? So if this is the case, what are we going to do? Well, what we are going to do is to apply a force again, okay? But as you are going to see a different force. In which direction we have to apply this force, okay? So we can create, for example, a vector 3, and we can specify this direction. So positive y-axis, okay? So we have to jump, okay, in the positive y-axis. This is correct, this is possible, But vector3 has an alternative, okay? So we can use a constant, it is called vector3 up, which is exactly the same thing, 0, 1, 0, okay? And of course, I can change the magnitude of this jump, okay?
By
And I can do exactly the
multiplying.
same I did in the case of the constant force. I can
Right,
multiply
of
this
course. Sure. Let's see if I can remember this without having to come back to the video. Okay, we got it. If okay, if get, what is it? Get button pressed? No, I'm not gonna. Input dot get button down. Sure. Jump. And we got the and. Who's calling me? Okay, hold up. Okay. Cool. So we got mathf abs. Mathf dot abs. Sorry. RB velocity. RB dot velocity dot y is greater than 0.01. That's a freaking 0.01 f because we have to convert it to a float. Sure. Except why did it do that? Do I not have to put brackets here? I feel like I do. But okay. What is it? Vector 3 dot up. Dot up. And then, I don't know, times 2. Sure.
Something. In this case, jump value, okay? So this is probably the most important thing to do here, okay? However, if we leave the add force as it is, the problem is that we are applying a constant force.
Do I not have to put curly brackets here? Do I seriously not? Or does it just do it? It just does it because of the spaces, I guess. Okay, whatever. Jump value. Sure. J value. What the heck is that? Okay, also, I love how inconsistent he is with the capitalization.
Okay, and this is not what we want. Okay, so we have to add another parameter. Okay, and this other parameter is force value. Okay, force mode. Sorry. So we can change the kind of force we are going to apply. In this case, it's not going to be a constant force. Okay, it's going to be one. It is called impulse. Okay, so with this we are saying that the amount of force we are going to apply is going to change the velocity immediately, not gradually like a constant force. Okay, so I'm going to simulate that somehow I'm kicking the sphere in the y-axis. So now the only thing I have to do is to add this attribute, this jump value. I'm going to make it public so I can change it in the editor.
Oh.
And that's all. We can
Never mind, I did that.
script, okay? And we can go back to Unity.
Oops, my bad.
So now if we select the sphere, remember, we have to be able to see this change, okay? Here it is. So as you can see, we have force value, and now we have jump value, okay? So we are going to put an initial value of, for example, 10, and we are going to see the result. So now we can move, remember, and if we press...
Okay, let's check it. Boy. What? Oh. Why did it switch this to 0? Alright, cool. He did 10. So let's just do it. Bing. It is not working. Did I do something different?
Press, in this case, the space bar, we jump, okay?
Did I do something wrong?
And now we have to be able to use Unity. And that's all. We can...
Vector 3 dot up. Okay, and then jump value. Force mode dot impulse. So what is going on? Did they change the jump value? Or no, did they change the jump here? The jump button? Okay, I changed. No. Should be fine. It's not working. Actually not working. Cool. Okay. I mean, here's the thing. This should be here, right? Am I like tripping out to think that This should be here. Or is that not supposed to be there? It's not working. Ah. If input dot get button down jump and math f. Oh. Okay, never mind. I had a greater than sign. I had a greater than sign instead of less than sign. Cool. I'm dumb. Wow. And it does it in the air too. That's poggers. That's poggers, bro. Bing bong, bing bong. Okay.
Save this script, okay? And we can go back to Unity. So now if we select the sphere, remember, we have to be able to see this change, okay? Here it is. So as you can see, we have. So if you see, if I'm over the plane, I can jump, but if I'm in the air, I cannot jump again, okay? Or if I press jump and I don't release the key, I only jump once, okay? This is also very important. So I can jump, I cannot carry out more jumps when I'm in the air. And if I press the button and I don't release the button, I jump only once, okay? So this is thanks to this compound condition we have inside the update, okay? So now we have another interesting functionality to our little example. So we are now able to jump.
Very cool. Very cool. So RB dot velocity dot y. Yeah, I'm definitely gonna need to use that again. All right, I'm getting kind of tired already. I kind of want to finish this section, like this section at least, before I get off. This is 3 minutes. This is 10 minutes. This is 9 minutes, but I'm watching it at a 1.5 times speed. So that's pretty good. All right. Yeah, that's fine. That's fine. Let's continue.
Prefabs with scenes, game objects, and components are another basic element in Unity. Let's see what a prefab is. A prefab is just a template of a game object. After creating a game object and adding some components, for example, to it, it is very common to create what we call a prefab, especially if we need several instances of this prefab, of this game object, and or its dynamic creation and destruction. Creating a prefab in Unity is very simple. Just dragging and dropping our game object from the hierarchy view over the project view. With that, a new asset, the prefab, will be created. And as usual, it's a good practice to create a specific folder, in this case for the prefabs, in the project view. From that moment, we can create as many game objects as we
Dragging and dropping our game object from the hierarchy view over the project view. What? Okay. JetBrains. Oh, JetBrains. Wait. Okay. No. I don't know why that opens it in Visual Studio if it's a JetBrains thing. But whatever. I'm guessing. I'm guessing he's gonna have us make another folder for prefabs.
We want from the prefab, just by dragging and dropping it over the hierarchy or scene views. After that, and this is very important, if we change the properties or we add new components, for example, to the prefab, all game objects created from it will be also modified. So imagine, for example, that we create a wall from a set of bricks. If the brick is a prefab, and I have created the bricks using this prefab, if I need to change something to all the bricks, I can do it just by changing the prefab. For example, if I need to add a collider to the bricks, or I need to add a rigid body to the bricks, I can do that only
The
by changing the
bricks,
prefab.
not the
I don't have to
bridge.
select and work with all
Whatever.
the bricks. The instances of prefabs appear in a different color in the hierarchy view, in blue, instead of white, the regular game objects. Prefabs will be also very useful when we have to dynamically create object instances in our scripts. For example, bullets when shooting. So now we know what a prefab is, more or less. But with real examples, we will be able to fully understand them.
True, poggers.
Okay, in order to understand the concept of prefab and to better understand also the physics engine, we are going to add to our scene some extra elements. We are going to add some cubes. Okay, so the very first thing I'm going to do is to go to the game object menu, and in 3D object we have cube. Okay, so if you create a new object and you have arbitrary positions, one possibility you have is to come here, and in this gear wheel you can reset, okay, the component. So as you can see, we
You
have
said that
as a result
before, but
that
true?
the cube is going to be in 0, 0, 0. So in our case, we are going to put it in 0.5, okay? So in order to move it, okay, over the plane, okay? Remember that we have the snap tools, okay? So in the edit menu, we have the snap settings. So we can make a snap.
He's just
okay?
reminding.
Let's put it again, 0.5.
Got it.
So by default, we are going to move 1 meter using the snapping tool. So this is going to be very interesting in order to move this cube and to make duplicates of this cube. Before making duplicates of this cube, what I'm going to do is to create a material. So remember, this is something we can do here. By using the right button, we can create a new material. I'm going to call it, for example, cube. And the only thing I'm going to do is to just select a color for the albedo. So I'm going to select something blue. And again, remember that the only thing we have to do is to drag and drop over the element, okay? So now we have a cube. So now the
Poggers,
thing
cube.
is that if we want to have duplicates of this cube, remember we can use Control D or Command D in Mac. But we are not going to do that, okay? Because it is not generally a good idea to do the things in this way. The best thing to do in this case, if you want to create duplicates of elements, is to create what we call a prefab. So remember, prefab is going to be a kind of template, okay, of a game object. So creating the prefab is going to be very useful because then, if we create instances of this prefab and we want to change a property, a component of all the instances, we can do that by just changing the prefab. So this is what we are going to do now, to create a prefab from this cube. So in order to do that, as usual, I like to create a folder for every single...
Poggers folder. Poggers folder. Okay, I can delete this. Right? I don't need this. Yeah, I don't need these. So, just gonna delete them. And then prefabs. Right? And then we're gonna make a cube. And then, okay. The real question is why? Why does it do that exactly? Like, oh, why does it do that? Can I zoom in more, please? Thank you. Boom. It doesn't matter. And then let's just do exactly what he did. Really? Oh, color picker? No, thank you. Blue is fine, I guess. And bang. Nice. So now we go to prefabs.
Kind of element we want to create. In this case, I'm going to call it, for example, prefabs, okay?
Oh, for
So with
example,
double-click,
thank you.
I'm in the prefabs folder. So I'm going to create a prefab from this cube. And in order to do that in Unity Editor, this is very easy. We go to the hierarchy view. We select the element, in this case the cube. As you can see in the cube, we have already some components, okay? Now we have the material, the blue material. So we have, let's say, prepared our game object in order to, from it, to create a prefab. So the only thing I have to do is just to select it and drag and drop inside the project view. In this case, inside the folder I have created prefabs.
Oh.
That's it, okay? It's the only thing I have to do. With that, as you can see, Unity has created a new element. It is called cube.prefab, okay,
Wow.
as you can see, with the extension prefab. And as you can see,
Easy
another consequence
enough.
is that in the editor, you can see that the prefab appears in a different color.
Let's rename this to block. And then bam, the magic has happened.
Blue, okay? So this means that this is a prefab, okay? An instance of a prefab.
Except why is this not blue? Okay. Sure.
Okay, so this is very, very interesting, very important. Now I can create duplicates. This is what I'm going to do. Okay, so I'm going to move, for example, this a bit like this. Okay, now I can create duplicates with Control D, Command D, Mac. So I can create some duplicates. This is what I'm going to do. Okay, some duplicates. Okay, as you can see, all the instances, all the duplicates I have created are in blue.
Welcome to Unity. I be doing it for 10 years since I was a teen. Dang, thanks. Thank you for the welcome. And yeah, I should have started much earlier. Actually, I didn't have a computer back then, so I couldn't have done it, but like I didn't have a good enough computer. You get it. You understand, but thank you for the welcome.
So they are in blue because they are prefabs, instances of prefabs, okay? The prefab is this one. So this means that if I want to change something of all these cubes, now I don't have to select them all and to change something in Inspector. As a matter of fact, it's not convenient to do it in this way. If I want to change something, I have just to select the prefab, okay? And to change the properties inside the prefab, okay? So we can open the prefab, as you can see.
Oh.
And here I can change all the properties of the prefab.
Yeah, I get it. I worked with the worst of the worst PCs back then. Yeah, I guess I could have made it happen, but I don't know. I wasn't a very ambitious child. I didn't really know what to do. Like, I didn't really think about the future. I just kind of went through life. I was just like, oh, this is school. You know, this is school. I gotta do school. I didn't really think about what happened after school. And my parents didn't really push me to like learn a skill that I could make money off of for the rest of my life. So I don't know. Maybe is it my fault or is it my parents' fault? That's the real question. Because they really, now that I think about it, they really didn't tell me anything that, like anything about what was happening after school ended. But also, I was depressed, and I still am, kind of, so whatever. One thing that helps a lot is learning things you want to make in Unity. My parents never knew about my game dev passion. Dang. Yeah. One thing is that if I have kids or when I have kids, I am going to try to instill in them the fact that you need to learn a skill to be successful in life, unless you like want to, unless you want to do some 9 to 5 job that you hate and that you want to kill yourself over. YouTube videos are good. Yeah, I'll probably go through multiple tutorials just to get a bigger picture. And obviously if I ever want to do something, I'm going to have to look up like how to do this specific thing. And then I'll just like put it all on a document. I'll be like, okay, delta time, or time.delta time. I'll probably remember that, but I'll put it all on a Word document until I remember all of it. Like every single line of code that this guy is typing, I will put on a Word document. Because I feel like the interface is somewhat intuitive, just the scripting part is a little bit difficult. Yeah, I'd like game dev to be my 9 to 5 job, but it's not easy at all. True. It's also that like some people have a knack for it, and like as with everything in life, some people have a knack for it, have a knack for things, for like certain activities, and other people, it's more difficult for other people. Usually with like math oriented things, or like what is the word for it? I don't know. I'm good at learning, or like learning. I'm good at learning things fast, but I guess to really get into the swing of things, it'll be more difficult. But I'm already like thinking about things that I want to do. I'll probably just make a game that's like my first game, and then it'll be like a cube with a sword or something. But yeah, something that I do have trouble with is video editing. I'm really mediocre at video editing. Or, well, like, I know how to edit videos. I don't know. It's just like the whole process of making a video. I guess I should say I'm not really good at producing videos, like music choice, scripting, voiceover, like the whole thing. I'm like very mediocre at. And I don't know, it may just be my software. Or I don't know. I don't know. I haven't made a video in a little while, so it's all right. I guess art. I guess, I should just say art. I'm just not good at like art. Well, that's subjective. Like writing is technically an art. You get what I'm saying. You know what I mean by art. But let's continue.
Basically, the thing we have to do, okay? So it's very simple, okay? So again, we have created a prefab, okay? If you
So
want
if I just click on this, if I just click on this,
to change and open the prefab, as a matter of fact, it's not convenient. All these cubes, now I don't have to select them all and to change something in the inspector. As a matter of fact, it's not convenient to do it in this way. If I want to change something, I have just to select the
oh, then I just go down here. All right, fair enough.
prefab, okay? And to change the properties inside the prefab, okay? So we can open the prefab, as you can see, and here I can change all the properties of the prefab, okay? This is basically the thing we have to do, okay? So it's very simple, okay? So again, we have created a prefab, okay? If you
I know what you mean, and I agree. We are coming slowly to a point where art type jobs will be what people want to do rather than robotic, not thinking type work. But we ain't there yet. I think we are definitely already there. Because like I want a creative job like this. Like I want to make games or I want to write or like be a voice actor or something. And I've had 3 jobs that were pretty much just bot jobs. I call them bot jobs. Just like what where you go to work and then you just like do the same thing for like 8 hours or 10 hours or whatever. And then you leave and then you come back and you do it again. You do the same thing again. And I couldn't handle. I could not handle those things. I do seriously think everything is going to be automated at some point, but I don't know if there are, what are they called? Robotics engineers, roboticists. I don't know if there are those people out there that actually want to automate everything bad enough. So, yeah, I mean, I think it's going to be a while since things are automated, but my generation, so I mean, we might be this like close to the same age, but I'm like the oldest Zoomer you can be. And Zoomers hate, most Zoomers, I would say, hate like 9 to 5 work. Or, sorry, bot jobs. They hate bot jobs. And I'm in the same boat, so.
you want to change any of the properties of these instances, you have to select the prefab, and in inspector you have here this open prefab, so you can open the prefab here, and you can modify here the prefab the way you want to add, for example, components, okay? And we can go here back, okay? And you are going to see that all the instances are going to receive these changes, okay? Well, as a matter of fact, as you can see, now my instances of this prefab, they have all box collider, okay? But they don't have rigid body. So the consequence of that is that if we run right now, the sphere is going to be able to collide against the cubes. But because the cubes don't have rigid body, they won't react with in front of this collision, okay? So they are going to be static from the physics point of view, okay? So let's see it, okay? So if we run, as you can see, I can move the sphere, so I can jump. I can jump on the top if you want, okay? So I try to collide with the cube. If you see, the cube is somehow rigid, okay? It's rigid. So we cannot push them, we cannot move them. And the reason is because they have just collider. They don't have rigid body. If they don't have rigid body, you cannot modify, you cannot affect them using any kind of forces, okay? So the rigid body is essential.
Okay.
So instead of selecting
Pretty
all the
epic.
cubes and add to them a rigid body, what we are going to do, of course, is to do that to the prefab. So we select the prefab.
Yeah, I also want to learn programming. And like, I want to be well, I have learned programming, but I haven't done any programming. You get what I mean? Like I've done a course, I just haven't made my own programs quite yet. But I feel like one day, or I think one day, I do want to make a language, a programming language, or a game engine. Even though I know no one recommends that, but I'm talking about years down the line, maybe like even a decade. So I shouldn't. I don't know if I even should be looking that far ahead. That far that far ahead. Gosh dang, bro, my voice crack. Ooh.
We open the prefab, and here in component, okay, in the menu physics, we have rigid body, so we add a rigid body. So as you can see, we have added a rigid body to the prefab.
Poggers, let's get it. But also, whoa. Why did that happen? Open prefab asset. Block. Is that on his?
So now we add the prefab, and
Oh,
here
it
in
is.
component, okay.
Never mind. All right. Bang. And then let's add that. Ooh. Oh. Oh, I see. That makes sense. Okay, and then we add a rigid body. So actually, if I wait, if I just start this right now, like if I just go back and I start this, then I can push this, right? Okay, why is it not? Okay, let me switch this to 0. Alright, 5, let me switch that to 5. Let me switch this to 0. And then, let's see. Except why is it not freaking... Okay. Wait, there should be no friction, bro. Wait, there should be no friction. What is going on? Is it that the corner? The corner is just... You're telling me it's getting caught on the corner? Okay. What about this? What would this do? If I do convex? Never mind. Wait, what is going on? Cooking options? Bro, I'm not cooking. What do you... Why did they call it cooking? Okay, you can change the things during being in game mode. Oh. Yeah, I know. It doesn't stay. Like whatever you change doesn't stay. If you change a value, it doesn't it doesn't save. That's kind of why I go out of game mode. Also, isn't there a short voice crack? I love it. Isn't there a shortcut for this? For the play button? Like space or something? Nope. It's not space. You don't know? Oh. Okay. Ging. Also, why are these shadows so not sharp? Yeah, these shadows are seriously not sharp. at all. Settings of your directional light. Oh. Alright.
In
Fair
the
enough.
physics, we have rigid body, so we add a rigid body. So as you can see, we have added a rigid body to the prefab. So now I can go back, okay? If I select now the cubes, as you can see, all of them, they have rigid body, okay? So this is a very interesting advantage of using prefabs, okay? If you have several copies of these
Thanks.
prefab instances, we call them instances in this scene. If you want to add, for example, a component to all of them, you have the opportunity to do that into the prefab instead of the instances, okay? This is going
Wait, actually, so I'm wondering, can I just like do this? Can I just change this to 0? Use gravity, interpolate. No. Collision detection. I don't know what that does. I don't know what the difference between those collision detections are. No? Okay. Why do the corners still... It should be completely frictionless by this point, right? What about this? So if this... No? Mesh, plane. Okay, material? No? Alright, never mind. I'll figure it out later.
to be convenient and very flexible. So now, for example, I'm going to create another copy of this one. And let's see now which is the reaction now, okay? Now they have rigid body, okay? So now, as you're going to see, if I collide with them, they move, okay? As you can see, there's a reaction, okay? There's a reaction when I collide against, okay, against the cubes, okay? Why? Because they have...
But for some reason they're not...
So as you can see, there's a reaction, okay?
They're
So,
like not coming
in
apart.
short, you have seen that it is very important, the concept of prefab. We use prefabs quite a lot in Unity Editor because they are going to save us a lot of work, okay? So the steps are very simple. We first create an initial game object. From this initial game object, we create a prefab. And then if we want to change the properties of the instances of this prefab, we do that into the prefab, okay? And remember, we have the option here, Open Prefab, where we can change whatever we want. And after changing the properties of the prefab, you're going to see that all the instances of the prefabs are going to have the consequences, are going to receive the consequences of these changes, okay? Another thing we have learned in this video is that if we have only a collider, the object is static from the point of view of the physics engine. If it has also a rigid body, of course, then the consequence is that it is going to react to the collision, of course, of other objects or the application of forces.
Cool. Alright, oh, adding a sound.
Okay, let's add a sound when we jump, okay? Something very interesting in many games.
Okay.
And with it, we are going to understand the very basic knowledge.
Something very interesting in many games. Sounds. Thank you.
To add sounds or music to your games.
This guy's not the
So
best
if we want to add
teacher.
sound in our game, we have to understand two important components that are related with the
whatever.
sounds and music in Unity. These two components are the audio listener and the audio source. The audio listener is going to be very important because the audio listener is going
Hey,
to be the
yes,
player's
they're both
ears.
very important.
So we are going to
Correct.
have one audio listener in our scene. And this audio listener, as I'm telling you, is going to be the ears of the player, okay? So by default, this audio listener is going to be in the main camera. So if we select the main camera, you can see here this audio listener.
Oh,
Normally we are going to put this audio listener normally in the main character. This is what I'm going to do now. So I'm going to remove this audio listener here. I'm going to remove it. And I'm going to select my main character, the sphere, and I'm going to add this audio listener in the audio section, audio listener, okay? So we are going to have one audio listener in the scene, and normally we are going to put this listener. Okay? And I'm going
component
to add
audio.
this audio listener in the audio section,
Okay.
audio listener, okay? So we are going to have one audio listener in the scene, And normally we are going to put this audio listener to where we want the ears of the player. Okay, in this case, in our example, the sphere. The second component we need in order to produce sound and music in our games is what we call the audio source. And we can have many audio sources in our scene. And we are going to attach this audio source to any game object able to produce a sound, okay? So after that, Unity is going to consider the distance between the audio source and the audio listener. So you're going to have a very natural feeling, okay? So depending on the distance between the audio listener and the audio source, you are going to see that, for example, the volume is going to change, okay? So in our game, we are going to put an audio source to any game object that can produce eventually a sound, okay? So this is going to be very interesting. In our case, what we want to do is...
Is it going to be very interesting?
So in our case, well, the sphere is
I
going
thought
to
it was
have
only
also
going to
the
be
audio
slightly
source, okay?
interesting.
But for example, if you want that our cubes,
Slightly
for example, they produce a
interesting.
sound when they collide with
Interesting.
something, we will put to our
Alright,
cubes
we're just
an audio
working on
listener.
my
In this case,
enunciation.
we will be doing that in the prefab, okay? Of course, as we saw in the previous video. So, okay, so what we are going to do now is to select the sphere, and in components, audio, we are going to add an audio source, okay? So as you can see now, we have a kind of a speaker, which is telling us that this element, the sphere, has an audio source. As I'm telling you, we can add many audio sources to any game object able to produce a sound, and even the same game object can have several audio sources, okay? Here we can see the properties of the audio source, okay? Some of them, okay? There are many properties. The most important one is the audio clip. The audio clip is going to be the sound we want to reproduce, okay? And we have other properties such as if we want the loop, the volume, the pitch, which is a kind of velocity when reproducing the sound, and other spatial effects, okay? What I'm going to do now is to import a sound, okay? And before doing that, as usual, I'm going to create a folder.
Which is
I'm
velocity?
going to call it sounds, okay? And double click. And I'm going to import, okay, a sound. It's very simple.
I guess
In
so.
the most important formats, in this case MP3, I'm going to just drag and drop the sound inside Unity in the sounds folder. Remember that the folders and the name of the folders are up to you, okay?
Alright, sure, I'll just do this. Sounds. Very cool. Then I'm going to drag my... Okay. I'm going to drag my bruh sound effect. What about this one? What is going on? Can I just play it, please?
That's a bit sussy.
Okay, that's a bit sussy. Do I have a spring noise? Yes. I have Mario jump. Where's Mario jump? Mario. Okay, jump. Oh, there it is. Okay. Sorry, this one. So, here we go, boy! We got the Ocarina of Time one, which is his voice. Which is him doing the hot. Okay. Bam! Nuts. Thank you. Alright. Cool. So, delete this. Can I delete this? How the heck did he delete it? Okay. Remove component. Oh. Thank you, thank you. I'm so dumb. But thank you guys for actually watching my stream. Just started today, so nice. What? So that's embarrassing for you? Okay. I'm going very slowly. Okay, this is a slow course, I would say. I have not watched a YouTube video. I have multiple videos queued up here. Okay. I have multiple videos queued up here. This one, wait. I forget which one is 7 hours.
I made
Okay.
Line.
This one is 7 hours. The free code camp one is 7 hours. And I haven't done that one yet. But yes, this is an extremely slow course. And also this guy is not very eloquent, unfortunately. So don't blame me because I'm beautiful. Okay, we got a listener and we got a source. Nice. So let's add that hacking audio clip. And let's make sure the volume is not gonna blast my eardrums out. So let's do like 10% volume. That might be too low, but whatever. Oh, and I actually haven't set it to play during anything, so let's just go back here and actually
So now
not
if I
jump the
select
gun on
the
this.
sound, okay, if I select the sound, you can see that by default, the format Unity internally uses is the Vorbis format. As you can see, it's going to be a 3D sound, okay, a stereo sound in this case, so we can preview the sound. Okay,
That
we
is
can preview the
such
sound
an
as a
awful
preview,
noise.
okay?
Wow.
This is the sound I want to
I
reproduce when we
really
jump,
hate
okay?
that noise.
So we can go to the sphere, okay? We have here the audio source. So now we can, in the audio clip, indicate that with drag and drop, okay? We can indicate that the sound we want to reproduce is the sound we have imported, the point sound, okay? You can use any sound you find,
Wow.
of course, in internet.
Thank you.
One of the things we can change here is play on awake, okay? By default is activated. This is good, for example, for music, okay? But in our case, we want to reproduce the sound by scripting, okay? So we are going to...
Wait, is that
enable this
on by
play awake.
default?
For music, for example, it could be interesting to use loop, but in this case, it's not the
Okay.
case, okay? So this
Why was it not? Wait. Okay, it does. It actually does play. And that is very soft, so let's do 0.5.
is the only thing we are going to do in the editor. We are going to just to indicate which is the sound we want to reproduce and that we don't want to reproduce when we run, okay, the application, display on awake. So in
Let
order
me
to
guess,
reproduce the
we're
sound whenever
gonna
we
write
want,
a
we have to
script.
change our script. So we go to our script move, okay? And here is where we are going to indicate when we want to reproduce the sound. And we are going to do it here, when we jump, okay?
Okay. So let's get it. And then what do we do? This is like play. I'm guessing that we do something like that. I don't know the method, but why is it? Okay, why do they not put brackets in C#? That's my real question.
Is something we already know. Whenever we have a component, we add a component to our game object, we can get access to it using get component, okay? So this is what
Yeah, get component.
is called audio source.
I should probably stop
Something we can call it,
dabbing.
for example, audio source,
Yikes.
okay? Audio source, for example. The very first thing I'm going to do in the start is to get access to it, audio source, with get component. So I'm going to use
A private audio source. For some reason, private, but alright. Sure. Audio source. And then audio source. And I'm guessing we do this? Wow. Equals get component And then we it here. For some reason that's not already put in. But alrighty. I'm thinking maybe we don't do that. Maybe we have to
Audio source.
name.
Sorry, audio source.
Okay. Did
So,
it
same thing we
correctly.
did with the rigid body. So this is very common to
The
use the
first
start, okay, but it
time.
is going to be executed only once when we run our scene. So to get access to this audio source. So the only thing we have to do here is to add an instruction. Okay, so in this case we need to open and close braces. Okay, because we are going to execute more than one thing. We are not going just to add a force.
Oh, that's why. That's why they don't have brackets. It's because if you're only doing one thing, then you don't need to put brackets. All right. Fair enough. I get it.
The sound. And reproducing the sound is very simple. We get access to the audio source.
Basically, you should
play.
always put brackets. I don't know why he didn't do that on the first thing.
So this is the only thing we are going to be doing, okay? So when we jump, we are going to reproduce this sound we have in the audio source, okay? So we save this script and we go back to the editor. So remember, the sphere has the audio listener, in this case, the ears of the player, and has also, okay, the audio source, okay? One audio source with the creep Boeing. And by using script, our scripting, okay, we are going to jump and we are going to reproduce
I
the
get
sound, okay?
back
So
to the
see, this is
video.
the result. So now we can move and jump.
Wow.
We reproduce the sound.
Very cool. Also, oh, this is just an exercise. Yeah, so Twitch used to not have this first time chat, like, tag, but, like, last time I streamed, which was a few months ago, like before day one, is what I'm saying. Whatever, you get it. But I think it's pretty cool. Wow. Let's turn that up, honestly. Let's turn that up to make it a little bit more clear. Why can I not make it any loud? Oh. Sure. Because that's 100% volume. No! 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 Okay, let's change this to like 2. And now I can just hop around. Now there's literally I literally can't get on the cube. Wait, if I put this friction to drag, if I put this drag to like 10 or something, then is it gonna like stop right away? No, it's just gonna make me move slow as heck. That's what it's gonna do. Actually, if I do this to like 20 and then I do this to like 5. And it stops pretty fast. Alright. Cool. Test the consequences of using different values of drag and angular drag. on the sphere. Test different values for the jumping force. Test different mass values. Okay, I'll do that. Mass. Let's do it. 10. Okay. Sick, and I'm assuming we're gonna have to make this more. Okay, and I literally can exit out. Fudge. Mass, what are the ranges? 10, 1, is that 100 billion? 100? Okay, it doesn't matter. 20. And then that to 0. It's like the same. It's like almost the same. No, it is literally the same. Okay, it just means... Okay, let's do 100. Which is just, it just means it's gonna go up 5 times, so. Or 5 meters or whatever. So if I do 100, are we doing, is this some F equals MA type? Oh, it is. Nice. And then let's just, aha! Ooh! Nice, got wrecked. Idiot. Alright, pretty pog. Module assessment? I don't care. Yeah, this is seriously a mega introduction. Because I'm already on the 4th section. And there are only 5 sections. Sorry, 6 sections. Whatever, I'm like more than halfway done. Which is like... Or I'm halfway done. Whatever, you get it. So... Definitely. So definitely super introduction. Super duper introduction. And then... Yeah. Yeah, let's just chill this the heck out. Yeah, that's it. That's it for this stream. Guys, thank you so much for joining me. And thank you for spending your most valuable resource, the time in your life, on watching my stream. Thank you for typing in chat. We got 3 unique chatters. Which is more than the last 2 times. The last 2 times I streamed. Gosh, can I stop cracking? Can my voice stop cracking, please? But basically, thank you. And have